Welcome back to Mathemedici. Today we are going to see the line graph. Before that, we take the recap of before video. Representing data. What is meant by representing data? That is a large set summarized to a short form of representation, which is easy to identify what type of changes have been occurred. On last video we see the bar chart and pie chart. Bar charts is represented by the bars drawn. It is definitely a discrete one. And the pie chart is represented by a circle like this. Do you understand? I think. Okay, now we move to today's topic, line graph. Line graph is a way of displaying data to easily see a trend over time. To draw a line, we need to plot individual item of a data onto a set of axes and then connect as each consequent data point with the line segment. First, we have to plot the numbers by using the x-axis and y-axis. Here the x-axis is time and y-axis is velocity. For example, if we take that example, a particle moves along a straight line. The velocity time line graph below shows its motion over a period of 50 seconds. Work out the acceleration of the particle during the first 20 seconds. What is the acceleration of the particle moving first 20 seconds is the first question. Calculate the total distance travelled by the particle over the 50 seconds. This is second question. First we have to find the acceleration of first 20 seconds. 0 to 20 seconds. Okay, let me see. Work out the acceleration of a particle during first 20 seconds. A question. Acceleration on velocity time graph is represented by gradient because it looks like a slope. So, gradient is equal to change in y divided by change in x. v2 minus v1 divided by t2 minus t1. Because of velocity in y-axis and time taken in x-axis. The line goes from 0, 0 to 20, 8. Substituting in the before formula, we get 8 v2 is 8 minus v1 is 0 and t2 is 20 and t1 is 0. We get 8 minus 0 divided by 20 minus 0. 8 minus 0 is 8, 20 minus 0 is 20. We cancel in, we get 0.4 meter per second square. This is the acceleration of the first 20 seconds. The total distance travelled by the particle over the entire 50 seconds are, for our convenience, split the graph into three distinct shapes. Split the graph into three distinct shapes. First we see that if we put a line like this, it looks like a triangle, and here we put a line, it looks like a rectangle, and here we put a line, we get this as a trapezium. Yes. First, 0 to 20 seconds looks like triangle and 20 to 40 seconds looks like rectangle, 40 to 50 seconds looks like trapezium. We know the area formula for all of three. We substituting in the formula, we get the answer. First we take that area A1 triangle is equal to half BH. we know the base and we know the height. Substituting on the formula, we get half into 20 into 8. That is x-axis 0 to 20, y-axis 8. Yes, this is a graph 1, 0 to 20 and height is 8. Substituting the value, we get 80 meter. And a rectangle A2, width into height. We know the width is 20 and height is 8. We get 160 meter. How the width is 20 here? Let's see in the diagram itself. Here 20 to 40. Yes. Making a straight line. 20 to 40 means 20 meter width and height is as usual 8. Substituting in the value, we get 20 into 8 is equal to 160 meter. Then area A3, trapezium. Trapezium, we know the area of sum of the parallel sides into width. We know the sum of the parallel sides into width 1 by 2. Here we make a line. First this line. This line is 8. Plus 32 into width is 50 minus 40. Width is 50 minus 40. So we get 10. We plus this, we get 40, and we minus this 50 minus 40, we get 10, and multiply that, we get 200 meter. Total distance is equal to 80, 160 A2 and 200 A3. We sum the three areas, we get the total area the particle have been travelled. Okay, now you can see that clearly. Okay, let's do the recap fast and furious. Line graph means this is a line graph. First we have to plot the numbers, putting the dot, and next we have to connect the consequent points to make a line segment. X-axis is always a time and y-axis is dependent variable which you have to change that. X-axis, for example, x-axis is a days or a week, and y-axis we earn the amount for the further weeks. For example, I will take the one question and we can see that a particle moves on a straight line and the velocity of timeline graph below shows its motion over a period of 50 seconds, 0 to 50 seconds. The work out the acceleration of the particle from first 20 seconds. First work out it. Here the acceleration of the velocity graph is represented by the gradient of a slope. Because it looks like a slope, we can use the accelerator, and by using the gradient formula and substituting the gradient formula, v2 minus v1 divided by t2 minus t1 means we taking the value from the point 0, 0 to 20, 8. We substituting the value, we get the answer. This is the acceleration of a particle from moving from 0 to 20 seconds. And then we have to calculate the total distance traveled by the particle entirely 50 seconds, 0 to 50 seconds. How we calculate means it is difficult to calculate the both all over the value. So we have to split out for our convenient, making the line to partition partition. So we have to put first 0 to 20 seconds, it looks like a triangle, and then for a 20 to 40 seconds it looks like a rectangle, and we put a line for a end, we get the trapezium. We know the area of a triangle, we know the area of rectangle, and we know the area of a trapezium. First we have to find the area of a rectangle, means we know that half BH, basement is 0 to 20, so 20 is the base, and the height is 0 to 8, 8 is the height. We substituting that, we get half BH, we get the answer of the area of the triangle. Next we have to find out the rectangle. We know that 20 to 40, 40, the distance is 40 minus 20 is 20 seconds, and the height is 8, so 20 into 8 is equal to 180, 160 meter as a rectangle, and the remaining one shape is a trapezium. We know the area formula, half sum of parallel sides into width. We know that half into sum of the parallel sides, we know 8, 32, so 8 plus 32 we get 40, and the width is 50 minus 40 is 10 seconds. So we find that total value, total distance the particle have been traveled is 440 meter. I think you have understand this line graph. Any questions, please let me know in the comment section. Thank you for, I will meet in your next section. Thank you.